In this video, we will talk about contrapositive, converse, and inverse of conditional statements. Given a statement, P implies Q, its contrapositive is not Q implies not P, its converse is Q implies P, and its inverse is not P implies not Q. Next, we will look at some examples. Here we are given this statement: if this month is January, then the next month is February. Here we can denote this part, this month is January, by J, and we can denote the next part, the next month is February, by F. So we are given J implies F. Now we try to write contrapositive, converse, and inverse of this given conditional. First, let's look at contrapositive. Looking at this form, the contrapositive will be not F implies not J, which in the given format will be the next month is not February. That will be not F. If the next month is not February, then not J. Not J is this month is not January. Is not January. So this is the contrapositive of the given conditional. Now let's look at converse. So for converse, we just flip the direction of the conditional. The converse over here will be F implies J. And this we can write as if the next month is February, then this month is January. So this is the converse. Now finally inverse. So for inverse, we keep the direction, but we negate both hypothesis and conclusion. So this will become not J implies not F. This we can write as if this month is not January, then the next month is not February. It's not February. All right, we are done with this example. Let's look at the next one now. The given conditional is if it snows, then it does not rain. So let's let S to be it snows, and let's let R to be it rains. First, the contrapositive. Well, before that, let's write the given statement in symbolic form. So we are given S implies not R. Here it says it does not rain, so we have not R. Now the contrapositive of P implies Q is not Q implies not P. So we negate both and flip the direction. So it will become not R implies not S, which is same as R implies not S. So this we can write as if it rains, then it does not snow, because we have not S over here. If it rains, it does not snow. This is the contrapositive of the given conditional. Next, let's look at converse. For converse, we just flip the direction of the given conditional. So we have not R implies S. This we can write as if it does not rain, since we have not R. If it does not rain, then S, then it snows. And finally, inverse. For inverse, we keep the direction, but we negate both the hypothesis part and the conclusion part. So we will have not S implies not R, since the hypothesis part is not R, which is same as saying not S implies R. This we can write as if not S. So if it does not snow, then R, so then it rains. This is the inverse of the given statement. Let's look at the next example now. If X is even, then X is divisible by 2. Let's denote this statement, X is even by E, and the statement that X is divisible by 2 by D. So we are given E implies D. So for contrapositive, we flip the direction and negate both of them. So we have not D implies not E, which we can write as if not D, if X is not divisible by 2, then not E, then X is not even. Then X is not even. Let's look at the converse now. So for converse, we just flip the direction. So the converse of E implies D will be D implies E. This we can write as if X is divisible by 2, then X is even. X is even. And finally, let's look at the inverse. For inverse, we just need to negate both the hypothesis and conclusion, but in the same direction. So this will look like not E implies not D. And this we can write as if X is not even, then X is not divisible by 2. So we are done with this example. Let's look at the next one now. If n is prime, then n is odd or n is 2. So here we have 3 statements. The first one, let's denote this by P. The second one, n is odd, let's denote that by O. And the third one, n is 2, let's denote that by T. Here we are given P implies O or T. So I'm going to put that in parentheses. Now let's look at contrapositive. So in contrapositive, we take the conclusion part first and negate that. So this will look like not O or T implies not P. Now for the first part here, not O or T, I can apply De Morgan's law and write that as not O and not T. Then we have implies not P. If you need more information on De Morgan's law, please look at our other video. Now we can write this as, first we have not O and not T. So we can say if N is not odd and not T. So and N is not 2, then not P, then N is not prime. So this is the contrapositive of the given statement. Now let's look at converse. For converse, we just flip the direction. The conclusion here now becomes the hypothesis. So we have O or T implies P, which we can write as if N is odd or N is 2, then N is prime. This is the converse of the given statement. Finally, let's look at inverse. The inverse is not P implies not Q. So we just negate both hypothesis and conclusion and keep the direction. So we have not P implies not O or T. Now again here we can apply De Morgan's law and simplify this a little bit. So this will be not P implies, this part will become not O and not T. This we can write as if not P. So if P is not prime, then not O and not T. So then N is not odd and N is not 2. So this is the inverse of the given conditional. Okay, we are done with this example. Let's look at the next one now. Here the given conditional is if N is divisible by 2 and N is divisible by 3, then N is divisible by 6. So let's denote the first part. N is divisible by 2 by T. The second part, N is divisible by 3 by H. And the third part, N is divisible by 6 by S. So writing this in symbolic form, we have T and H implies S. Okay, so now let's try to write the contrapositive. So for contrapositive, we negate both the hypothesis and conclusion and flip the direction. So it will look like not S implies not T and H. And we can simplify the second part here using De Morgan's law. This will become not S implies not T or not H. So this we can write as not S is if N is not divisible by 6, then we have not T or not H. Then N is not divisible by 2, or not H. So N is not divisible by 3. This is the contrapositive of the given statement. Now let's look at converse. For converse, we just flip the direction. So it will become S implies T and H. This we can write as if S So if n is divisible by 6, then T and H, then n is divisible by 2, and n is divisible by 3. Divisible by 3. So this is the converse of the given statement. Now, inverse. For inverse, we negate both the hypothesis and the conclusion parts and keep the direction. So this will look like not T and H implies not S, which we can write as not T or not H using the De Morgan's law, implying not S. So this we can write as if n is not divisible by 2, or so not H, n is not divisible by 3, then not S, then n is not divisible by 6. So this is the inverse of the given conditional. Okay, we are done with this example. All right, so now we want to look at if any of these forms, contrapositive, converse, inverse, are equivalent to the given conditional. When we did the examples, you might have noticed some of them sound equivalent. Let's look at one more example and see if they sound equivalent. Let's say we have a given conditional. If it snows, then school closes, or then schools close. So let's say we are given this conditional. Its contrapositive will be if schools close, then it snows. We can write this in a little different way so that it makes more sense. We can say if schools are closed, then it has snowed. This is the contrapositive. Now, if you compare this with the given statement, they mean the same thing. Let's look at converse. Converse would be if schools close, then it snows. Now this one sounds little different from the given statement because the given statement doesn't say anything about what happens when schools close. There may be other reasons to close the school. So you can't conclude it has snowed just because schools were closed. So this one is not equivalent to the given statement. Now let's look at inverse. Inverse will be if it does not snow, then schools do not close. Okay, this is the inverse of the given statement. Again, the given statement does not say anything about what would happen if it does not snow. It only says what happens if it snows. So this is also not equivalent to the given statement. But you might have noticed that these two are equivalent. Inverse and converse are equivalent. So let's verify what we just saw using truth table. I'm going to try to draw the truth table here. We have P, we need Q, we need not P, we need not Q, we need P implies Q, we need not Q implies not P, we need Q implies P, and we need not P implies not Q. So we need truth values for these combinations. Let me draw lines so that we have a table. So now we look at all the possible combinations of truth values of P and Q. For that, we can have true, true, false, false here, and true, false, true, false. Not P is the negation of P, so we have false, false, true, true. Not Q is the negation of Q, we have false, true, false, true. P implies Q. True implies true is true. True implies false is false. False implies true is true. And false implies false is also true, vacuously true. Next, we have not Q implies not P. Not Q is this one, not P is that one. So false implies false is true. True implies false would be false. False implies true is true. And last one, true implies true is also true. Next, we have Q implies P. Q implies P. True implies true is true. False implies true is also true. True implies false can't be true. This will be false. False implies false is true. And finally, we need not P implies not Q. False implies false is true. False implies true is also true. True implies false is false. The last one, true implies true is true. So we have these truth values. Now we can compare these columns here. This is the given conditional. This is the contrapositive. This is the converse. And this is the inverse. Comparing the truth values, we see that this given conditional is equivalent to the contrapositive because you see the truth values are exactly the same. And similarly, the converse is equivalent to inverse because the truth values are exactly the same. So you will see often in proofs, it may be easier to prove contrapositive compared to the given conditional. So people like to prove contrapositive instead of the given conditional. And proving the contrapositive will prove the given conditional because they are equivalent. So this is all we have about conditional and their forms of contrapositive, converse, and inverse. We will do more examples and talk a lot more about this in our next videos.